Thanks for watching this screencast. The objective of this screencast is learners will be able to determine whether or not the inverse of a function is also a function given its graph. By now you know that the inverse of every function is not also a function. We worked some examples in class where we found the inverse of a function and that inverse was also a function. And we found some examples where the inverse of the function wasn't a function. We're going to focus on that in today's screencast. So this is from way back in Learning Target 3 early in our year. And we talked about whether or not a function is one-to-one. One-to-one right there. A function is one-to-one if every y value has only one x value. Here were the two examples we looked at in class together early in the year. This function right here, which we now know is y equals x squared, is not one-to-one. We gave you the example right here of when y is 1, x could be 1 or negative 1. This y value, in fact, all of the positive y values have more than one x. There's 2 for each. This is not a one-to-one function. But this function is one-to-one. Every y value in this graph has only one x. This is a great example of the difference. We also said in Learning Target 3 that a quick way to look at a graph and determine whether or not the graph of that relation was one-to-one was to use the horizontal line test. So here is the definition that you need to know. If we've got some function f of x, the inverse of f of x is also a function if and only if, meaning it goes both directions. It's only a function also if f of x is one-to-one. Or in other words, if f of x passes the horizontal line test. So here are those same two examples. This is the function that fails the horizontal line test. This function is not one-to-one, which means if this is the function, the inverse is not a function. We can even draw the inverse. If 0, 0 is on the function, 0, 0 would be on the inverse as well. And the same is true for 1, 1. If 2, 4 is on the function, 4, 2 would be on the inverse. But the inverse also contains, if negative 1, 1 is on the function, 1, negative 1 is on the inverse. And so is if negative 2, 4, 4, negative 2. So actually the inverse is this sideways opening parabola here that does not pass the vertical line test. It's not a function. So instead of maybe necessarily needing to sketch the inverse, you could just decide whether the graph passes the horizontal line test. This function is one-to-one. Its inverse, any horizontal line you draw there would cross the graph at only one point. So it is a one-to-one function. And what that means is that the inverse of that function will also be a function. So essentially you've got to decide whether or not the function is one-to-one. Okay, here's what we've got for you to try before the video's over. There are 6 function graphs here. And our question simply is which of these functions have inverses that are also functions and which ones do not. Why don't you pause the video, see if you can make a decision, and when you think you've got it sorted out, hit play. Panthers, we're essentially asking you which of these functions pass the horizontal line test. So I see one right here that passes the horizontal line test. I will do in green the ones that have inverses that are also functions. This one right here passes the horizontal line test. Any horizontal line you might sketch through there will cross the graph at only one point, which means that every y has only one x. And if every y has only one x, then when you find the inverse, every x will have only one y, and it will be a function. So this one here, I think this one here has an inverse that would also be a function. It passes the horizontal line test. I think this one here does not. I think the only other one that passes the horizontal line test is right here. For every horizontal line I might sketch through here, I believe we're only going to cross the graph once, this sideways opening parabola. And if I think about what the inverse of a sideways opening parabola would be, it would be an upwards opening parabola, a quadratic function, and those are functions, yeah. So the three that do not, that fail the horizontal line test, I believe this one here, this one here, and this one here. Every one of those has at least one y value with more than one x value. This one has infinitely many. Every one of these fails the horizontal line test, so these functions have inverses that are not functions. Do you have it sorted out now? Thanks for watching.